You can do the use can be confusing at this stage. So whatever's in there is this. Whoops. Do that every time. It's the sine of 3x minus 2, and then you do the derivative of the next function. So that's the cosine. And remember, the inside of the sucker doesn't change. And now we get to the chocolate part, which is the derivative of the last function, which is here, which is 3. You can leave it. On the multiple choice exam, you'd have to remember to multiply the 3 and the 2. 6.
Oh, that's
Yeah.
would be 6 times those 2.
Yep. And then the book, the reason why I chose this problem when I was looking through the solutions is the book uses a trig identity. It uses this one. It's the sine of 2 theta is equal to 2 sine theta cosine theta, which is why my answer looks different than what's in the back of the book, because they transformed it. We don't care. We're not going to do it. That's why you want to go online and look at the solutions. Because this is, see this? That's equal to the sine of 2 times that angle. And the 3 is out in front. They would not, I don't believe they would ask you to do that on the exam, because that's not what they're testing. This 3x minus 2 is an angle. We always take sines of angles. I don't know what x is. So you can have, like, x is 0. You can have the sine of negative 2 radians. I'm just going 2 radians. Radians is about 60 degrees, so it's about negative 120. These are angles. Okay. There we go. I'll give you some time. Let's try this. The hard part is the schematic. It's not really hard, but you guys think it is. How do you find the velocity if that's your position? We have particle motion, and we have it on the quiz tomorrow. And I have an extra practice problem on here, okay? How do you find, what is velocity? Velocity is the derivative with respect of the position with respect to time. How do you find the acceleration? Okay, so let's find those. I'll give you some time to find those. These require a little more thinking. No, I'm not going to get this to you yet. What's the derivative of 3t cubed? Yes, you do.
3t cubed is 3t squared.
Yeah, write it down. We have to do every term. That's over here.
Wait, what? No.
Do you have a sheet? You don't have a sheet? Well, you can finish the problem, though. Is a change in your position over the change in time. If you change this time a little bit, maybe t is equal to 1 and they make it t equal to 1.1, just a little bit, doesn't your position change? Yes. That's what this is measuring. How much does your position change if you change the time? So that's just the derivative. So that's what it's saying. That's just the derivative of the position. So what is the derivative?
Oh, is the velocity just the derivative?
That's all it is.
So it's 3t squared minus 12t.
3t squared minus 12t plus 9. Nope, acceleration is just the derivative of the velocity. So when you stop at a stoplight, your velocity is 0. When you get up to speed, your velocity is 55. We like cars that accelerate fast, don't we? So maybe, how fast do the race cars get from 0 to 55? I don't know. 2 seconds? I have an Infiniti G35. Let me tell you, it's very short time. You go 50. I should measure it. Divided by your time, maybe it takes 2 seconds. That's your acceleration. That's your average acceleration. Your instantaneous acceleration is the derivative of this. What's the derivative of that? 6t minus 12. No, it's the derivative of the velocity. So I just have to take the derivative of 3t squared. It's the change in your velocity divided by your change in time. These are what we call rates of change.
So that's not asking if I'm an instantaneous.
Yeah, it is.
It is. So whenever
If they have to say average, the question is that instantaneous? Yes, because if they want average, they will have to give you an interval from 0 to 10 seconds. Yeah, and then you just calculate slope. The average velocity, average acceleration is just the slope of the secant line. Remember secant lines? If you have a curve, this is called a secant line. The spider was an instantaneous. Yeah, because it's your line of sight. Because the physicists chose to do it that way. Well, you don't want D, because then otherwise you get dd, dt, and it's hard to say, it's confusing. So they usually use S, or if you're in vectors, and they're talking about your horizontal position, which will be X, or your vertical position, which will be Y. So you could use, you could use H too. For what? No, average is just the change, it's just the slope of the line, of the secant line. No, this is just the derivative of the velocity. This is the change in velocity over the change in time. Teeny tiny though, really tiny. So this is, here's delta t, here's delta v, where this, the points are really close together. Well, I've got to be on the curve, that helps. And so I could draw a little triangle here, which I will when we get into linearization. And then it'll be the change in the velocity divided by the change in time. Rise over run. The D is just mean it's a little tiny change, like 0.0001. Remember the lab? It's just the derivative of the velocity. Keeping it simple. Okay, how do you know which direction the particle is moving? Lauren, do you remember? Tom? How do you know which way the particle is moving? You're moving to the left if what? Velocity has to be what? Less than 0. Velocity gives you the direction. Okay, Alex, got that? And you're going to the right when the velocity is positive. So we have to figure that out. So I'm going to try and figure out what this particle is doing. I could graph it on my calculator, but I don't want to do that because I have to use parametrics. Okay, so where's my velocity? This is my velocity, right? So I need to know, where does it change? Where does it change from forward to backwards? What has to happen to the velocity for that to happen? Okay, does that make sense, girls? What does the velocity have to be if you're going to go forward and then you're going to go backward? You have to stop, don't you? So we're looking for the place where this particle is going to stop before it can change directions. If you're in reverse in your car, you have to stop.
It's the left and right, always right.
Yes, and also if it's vertical motion, if it's up, the velocity is positive. If it's down, the velocity is negative. We just all have chosen to accept this. Does it make sense? Okay, where is that 0? How do I do that? First off, I don't want to factor that yet. I want to either factor, I don't want to factor it by as a quadratic. I want to factor out the greatest common factor. So then, it's t minus equals 0. Don't forget equals 0 is mathematically incorrect without it. And I can only think of two factors of 3, which are 1 and 3. So it stops twice. Okay, so it's going to stop at t equals 1 and t equals 3. I'll move my table. I'll do the table in a second. Because we're going to try and see what we're going to try and watch what the particle's doing. Now I can bring my calculator. I can go to parametric mode and show it to you. It says, so I want to know when the velocity is negative and when it's positive. So I'm going to make a little, I'm going to cross that out because I'm going to do that later. Okay, it's 1 and it's 3. Now you can test the regions. Okay, Jason? You can test the regions here and see where it's positive, where it's negative by substituting values into this equation right there. Or you can be a little more clever than that and say, oh, that's a parabola. I know it's going to look like this. Those are the zeros. right? It's just a quicker way to do it, but you can certainly try 10. If I put 10 into this equation right here, that's positive, so this is all positive. These, and we have to get this concept because it's going to be coming up again. These are the only places where this is going to change from positive to negative. There are no other candidates. So you can blindly just test the regions. What number would you test in here? 2. Well, this is positive, and that's negative. So this is going to be negative. Well, sure enough, my parabola is below the x-axis. And then, or t-axis in this case. So it's the next easy number to test. 0. So this becomes -1 times -3, which is positive. But I already knew it was positive because of this. If I know what these functions look like when I'm looking for zeros, I can just quickly sketch them and I can know if it's positive or negative. Doesn't matter. So when is it going to the left? When the velocity, and this is what you would write on the exam. You would have to say this. It's going to the left, velocity is less than 0, and that's where? Between 1 and 3. Now, if you're now they don't get too particular about the parentheses if you include or not, but honestly, can you include it? What's happened at 1 and 3? You're stopped. You're not going any direction. So you really shouldn't have it in there. Sometimes they're just not that picky about it. Depends on the chief reader and how picky he's going to want to be. And you're going to go from the right, from -infinity to 1, and they may restrict it, saying our time will start at 0. You could talk about where were you. Can T be negative? Where were you 10 seconds ago? You can talk about where you were in the past. That would be a negative time. Generally speaking, they'll give you maybe a domain saying 0 to infinity, in which case then this would be a 0. But I would include 0. Why would I include 0? What's the velocity at 0? It's not 0, it's positive. Those are little subtle details that are easy to overlook. Even after doing this for 20 years, I can overlook those. I don't think I get a perfect AP. Pretty close, but not perfect. You may write the middle one, that t is between 1 and 3. You have to have the right order. So to do this, and this is going to go from 3 to infinity, I can say t is less than 1 or t is greater than 3. But you can't write this as this is called a compound inequality. You can't do that. It's not allowed because you can't have this. How would you do this? 1 greater than 3. That's not okay. And it will be marked wrong. So if they're not intersecting, you're going to have to write them into pieces. So that's why I kind of like interval notation, but I go back and forth. Okay, and we're going to do a schematic of the position, but let's do a table. And this is not meant to be hard, but I don't know, we make it hard, I guess. All I want to know is, given the time, and I could do this on my calculator if I'm really lazy, I want to know the position. And the position was, what was it? T cubed. And you'll want to use a calculator to evaluate this. Was it t cubed minus 6t squared plus 9t? Is it plus what, 9? Okay. And you might even want a velocity. There's a t there, right?
No.
Oh, boy.
I'll look. 9t. Okay. And the reason why I want the velocity, because I know it stops there. So what are 2 key t values I'd like to find? First up, I'd like to know where you start. You don't always start at the origin, but do we start at the origin here? Yes. Well, substitute 0 right in there. This is telling you where you are. It's a one-dimensional graph. It bothers you. You want a two-dimensional graph, but it's not. And the velocity was, I almost rather have it factored, but you guys don't. Let's do 3t squared minus 12t plus 9. Okay, what's the velocity at 0? 9. Substitute 0 in here, you get 9, which means it's moving which way? To the right. And then at t equals 1, we know the velocity stops. The particle stops. Sorry, I said that wrong. So v is 0 here, so we're stopped. Where are you at 1? So you put 1 in here, 1 minus 6 plus 9 is 3. And the next place it stops is going to be at 3, right? So this is also 0. It stopped. And anybody figure out what S of 2 is? 2 cubed. Well, this is not bad. Minus 6 times 2 squared plus 9 times 2. Can we do that in our head? I put 2 in right here. This is 8. 4 times 6 is 24 plus 18. So that's a 2. Trust me on the arithmetic. What's the velocity there? Well, it's going to be 3 times 4. Notice I just square the time. Minus 12 times 2 plus 9. So 12 minus 24 is negative 12. What did you say, negative 3? Yeah. So that means it's what? It's going to the left. Right? Ooh, what's S of 3? Okay, S of 3 is 27. This is the part I don't like. I want to do the arithmetic. 3 squared is 9 times 6 is 54 plus 27. Oh, I'm back at 0. This is the position. We're going to graph it in about 2 seconds. Can I move that thing? Well, I'd like to get one more point, because what happens at 4? What's the velocity at 4? It's 3 times 4 squared. Anybody know what that is? 48. So it's 48 minus 4 times 12 is 48 plus 9, which means it's moving to the right. And it's speeding up. You were 0. Now you're at 9. I'm going to guess it's going to speed up. How do you know if things are speeding up and slowing down? You look at your acceleration and your velocity. Right, and I'd have to look actually at that, and I didn't do that. But okay, and I don't know where S of 4 is. We'll probably find out. See, 4 cubed, what's that? No, 4 cubed. 4 times 4 is 16 times 4 is 64. Minus 6 times 16, 96. Okay, why am I good with arithmetic? We didn't have calculators. And I've been doing this for a long time. I don't get my calculator on. I'm lazy. 9 times 4 is 36. So this is 64 minus 96 plus 36. I want to do my pluses because what's 64 and 36? No, it's 100. 100. 100 take away 96 is 4. Okay. You can always graph something with a table. You can always do that. All the question is asking for is the schematic. Let's see if I can move that line down, or maybe not. Hang on. I can't. Okay, we're just gonna plot it. I want to see what the particle's doing. If you want me to bring my calculator up and put it in parametric mode and show you it's just going back and forth. This particle is on this line. I'm not going to draw it on the line because I'm going to be in trouble. So here's my position. This is S of t. Okay? Oh, we don't even go left, so let me move this over here. We don't go, we do a negative 3. Never mind. Here's S equal to 0. Okay, guys, ready? S equals 1, 2, 3, 4, negative 1, negative 2, negative 3. And all I want you to do is graph what the particle is doing. So this is all I'm asking you to graph. When the time is 0, where are you starting? So it starts here. Does it have to start at 0? The particles have to start at the origin? No, they don't. Think of this as hockey. You're going to puck those there, and it's going to come back, and then it's going to go back there again. Well, I can't just draw a line that does this because you never see what happened. So I have to cheat a little bit. Okay, at t equals 1, and I would label this. T equals 0, S equals 0. It's called a particle motion graph. And what they will ask is if it speeding up or slowing down. That's really what they're going to ask. At t equals 1 second or minute, whatever, we are at 3. And we knew we were going to the right, didn't we? So I'm going to be here. So this shows me what I'm doing. I'm going to move this way. That was at t equals 1. What happens here? S is equal to 3 and V is equal to 0. So it's going to stop. And if I put on my calculator, it's going to be going fast, but it's going to slow down and stop. And then it's going to turn around. And at t equal to 2, it's going to go all the way back to negative 3. So it's going to go back here. Well, I can't draw it right on the same line because you won't see anything, so I'm just going to do this. And what happens at, oops, did I miss one? No. Right here. Oh, it goes to 2. Excuse me. You know what? I read the wrong one. That's okay. That's why I got my negative. So it's going to go to 2. Always use pencil. Okay, so there it is. At t equals, thank you for calling me on that, 2, s equals 2. It's going to the left because it's negative. And then at 3, it gets back to where? It gets back to the origin. And what's it going to do there? It's going to stop. I'm out of space. T equals 3, s equals 0, and then it's going to turn around again because we know it's going to go to the right because it's positive, and it's going to get back up to 4. So it's doing this. Yeah, it's doing this. It's stopping, it's coming back here, and it's doing that. Now, would you like, I mean, I can put it on my calculator, give you the worksheets, and take me a second to do that. And if you want to see the motion, I can show you the motion. It's up to you. Okay, and that's all it is. And by the way, it's a 1-point question. So if you don't get it, it's not the end of the world. But that's all it's doing. You're just trying to say, what's the motion look like? It's just doing this, going back and forth. Okay. Maybe we'll get these done in class, and then, since you haven't done homework anyway. And then this is good practice.